This was the most often missed problem from the assignment that I think is due today. And so let's look at it. This is factor by grouping. Always, always, always you look for GCF first. So you write down the problem and you factor out the GCF. Once you have it, the GCF factored out, then you break it into two groups of two. The only thing that factors out of 3 and 5 is 1, but they both have an x squared. 27 and 45 are both, you can factor out a 9, and whatever this sign is what I'm supposed to use there. So when I factor an x squared out of this, that's going to be a 3x plus 5. When I factor a negative 9 out of this, 27 divided by 9 would be 3. The negatives cancel. 45 divided by 9 is 5. The negatives cancel. When you get to this step, if you have used the GCF, see if you used a 3 here instead of a 9, then these would not have matched. But if you use the GCF, then you should have a matching term. And so 3x plus 5x squared minus 9. I'm not quite finished because 9 is a perfect square number. This part will factor some more. This part factors into x plus 3, x minus 3. Where did I get the 3? Are you getting better at recognizing this perfect square pattern? Now, in some of my answers, I saw something squared. Are any of these terms exactly the same with the same numbers and the same signs? There's nothing squared here. They're kind of misinterpreting something I did in a previous example. This is the completely factored answer. So, do we think we understand the two groups of two thing and factoring it at least this far? Some of you may have missed that last step. Can we factor with two groups of two? Because now we're going to use that method on this kind of problem. This method is going to allow us to factor these kind of problems where the A is not equal to 1. What's the A in this problem? And what's the B? Not 1, but negative 1. The sign's important. Okay. But factor by grouping has to have two groups of 2. Can I do two groups of 2 in this form? I am going to have to break it up so that I can have two groups of 2 so that I can use the steps that I just learned. But step number 1 is always GCF first. Is there a GCF here? And I just forgot to turn this back on here. No, I didn't. Okay, so still, after you have the GCF, this one doesn't have one, then, like we did before, you multiply the A times the C. What's the A times the C? And you see I'm doing this kind of over here in the far margin of my paper. And so this I'm kind of doing over to the side. So what are the factors of 42? 1 times 42 and 2 times 21, 3 times and 14. 4 won't go into it. 5 won't go into it. 6 will go into it. Now, if this, let me start here. If this is negative, the bigger number has to be negative. If the B is negative, the bigger number has to be negative. If this AC is negative, then they have to be opposites. So, do any of these pairs add up to give me the negative 1? So, do you see that so far it was like just factoring a regular trinomial? Here's where it's different. The factors here are not x plus 6, x minus 7, because when you did the box problem, you wouldn't get this. It's a little bit more complicated than that. What I have to do now is break this up into is that equal to the negative x? If I added those together, would that be equal to the negative x? And I haven't done anything with the 2x squared. It has to come down, and the negative 21 has to come down. What I have done is I have replaced this with these two terms. These two terms have to add together to equal that, and they have to multiply together to equal the AC. Why did I do that? Didn't that just make it more complicated? I took a trinomial and made it into a polynomial. But now I have two groups of 2. That's why I did it, to break it into 2 groups of 2. Can I factor something out of this group? Can I factor something out of this group? And if this is negative, I need to factor out a negative. Do you see now I'm back doing exactly what I was on the previous assignment? The 2x factors out. 6 divided by 2 is 3. The negative 7 factors out. The 7's cancel. 27 divided by 7 is 3. Negative divided by a negative is a positive. When you get to this step, if you have used the GCF and the correct factors here, you should find a common factor. Let's check it out. This is x plus 3, 2x minus 7. Combine like terms. This is what we started with. You can hopefully really see that we're working the box problem backwards. We take this and divide it up. Aren't these two terms the two terms we put in there right there? What we are doing is backing this up. We're taking this and dividing it into these terms, and then we're finding these factors on the side. Okay, what were those steps? We are on example number 3, 3x squared minus 4x minus 15. The A is equal to 3, the B is equal to negative 4, the C is equal to negative 15. Before I did that, I should have asked myself, does it have a GCF? GCF is first, because of the 4 there, it doesn't have a GCF. So over here, all the way in the margin, I need to multiply the A times the C. What's the A times the C? The factors of 45 are 1 times 45. 2 doesn't go into it. 3 times 15. 4 doesn't go into it. If this is negative, the bigger number is going to be negative. If this is negative, they're going to be opposite. Could any of those pairs add up to give me the negative 4? If the A is equal to 1, those would be your answer. If the A is not equal to 1, then you have to replace this negative 4x with positive 5x minus 9x. Isn't that equal to the negative 4x? You still have the 3x squared, you still have the 15. That is equal to the problem I started with. But the reason I did this strange thing is so that I could have two groups of 2. What factors out of this first group? X or 1x. 9 and 15, what factors out of 9 and 15? And if this is negative, this needs to be negative. When I factor out an x, that's going to leave a 3x. X's are going to cancel. Do you understand where I'm getting the 3x plus 5? I'm going to factor out a negative 3. 9 divided by 3 is 3, has an x. 15 divided by 3 is 5. Negative divided by a negative makes a positive. When you get to this step, if you have used the GCF and you haven't made a sign mistake, you should have a common factor. You do not have to check every problem, but you should be able to check if you're not sure. (3x squared, 5x minus 9x, and minus 15. Combine like terms. Do you see that the check is exactly backwards to solving the problem? This negative 4 divides into these two terms. Then that allows these to be the factors that give us the box problem. 12a to the 4th b minus 14a to the 3rd b squared plus 4a squared b to the 3rd. First things first. Do you remember the first thing? GCF. 12, 14, and 4. What's the GCF going to be? They all have at least an a squared or bigger. They all have at least a b or bigger. 12 divided by 2 is 6. The a to the 4th and a to the squared, this is going to cancel out 2 of those, and it's going to cancel out the b. 14 divided by 2 is 7. The a squared is going to cancel out 2 of those. The b is going to cancel out 1 of those. Two will go into 4 2 times. The a squareds will cancel out. That'll cancel out. There's the A, the B, and the C. What am I going to get when I multiply the A times the C together? Positive 12. So positive 12 is 1 times 12, 2 times 6, and 3 times 4. If this is negative, the bigger one is going to be negative. If this is positive, they have to be the same. If this one is negative, the bigger one has to be the negative. If this one is positive, they have to be the same. Because positive times positive makes a positive. Negative times negative makes a positive. Do we have a pair? That's going to make the 7. So we have this 2a squared b that's going to be hanging out in the front. Now put brackets there instead of parentheses because some parentheses are coming up. And then instead of having parentheses and parentheses, I'll have brackets and parentheses. The first term stays the same. The last term stays the same. This gets replaced with these 2 terms. If I added those 2 terms together, they would equal this, but the reason I needed to break it into 2 terms was so that I could make 2 groups of 2. What's the GCF for 6 and 3? And they both have an A. What is the GCF for 4 and 2? If this is negative, this needs to be negative. And they both have a B. 2a squared b. And I'm going to factor 3a out of that first pair. 6 divided by 3 is 2. One of the a's will cancel. 3 divided by 3 is 1. The a's cancel, and I'm going to have a b. Going to factor out a minus 2b. 4 divided by 2 is 2, and the b's will cancel. 2 divided by 2 is a 1, and that would be a negative 1, and one of the b's cancel. If you have used the GCF and haven't made a sign mistake, when you get to this step right here, you should have a matching term. Now, at this point, I don't need my brackets anymore. The GCF just goes out in front. Before you multiply anything together, before you start trying to find factors, the first thing you do is GCF. What is the GCF? 24, 26, 8. Well, 4 will divide 8 and 24. Will 4 divide 26? No. If this starts with a negative, I factor out a negative because it confuses my mind to try to have that many negatives in the problem, or to have an A that's negative. That makes it harder for me to factor. And so if I take out a negative 2, the negatives are going to cancel. This is the A, the B, and the C. What do you get when you multiply the A times the C together? Did I multiply correctly? The factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. If this is negative, the bigger one needs to be negative. Where? Oh, what did I factor out? I factored out a negative 2. So what kind of 13 should this be? So this was negative, negative, positive. So it should be positive, positive, negative. Okay, now I got my sign mistake fixed. And so if this is positive, the bigger one needs to be positive. If this is negative, they must be different. So could any of these pairs add up to get you a 13? Would that add up to be a 13? So this would become 12x squared. This 13 changes into a minus 3x plus 16x minus 4. The reason I did this is so that I can make 2 groups of 2. Let's see what factors out of that. And what factors out of that would be 4. If this is positive, this will be positive. What? If this is positive, this is positive. What? No. This is positive. This one would always be positive because I'm forcing my A to be positive by factoring out a negative if if this is not a positive. 12 divided by, well, let's get this 3x out in front. 12 divided by 3 is 4. X squared divided by x is x. 3x divided by 3x is 1. 3 divided by 3 is 1. 16 divided by 4. 4 divided by 4 is 1. Negative divided by a positive is negative. Right here, if you hadn't helped me catch my sign mistake right here in this step, I would have caught it, because if I have not made a sign mistake, if I have used my GCF, this will match. There is one and only one way that I know of for you to learn this process. That is for you to practice this process until it becomes something that you can do easily step by step. So at this time, you need to do your practice problems.